Thanks for coming to our April Lunch and Learn. It's hard to believe we're in mid-April already. Welcome. We're glad you could be here. I'm Julie Brown. I'm the Raptor Migration and Programs Director at the Hawk Migration Association. And I'm joined by Josh Haas today, who a lot of you know. And Josh runs Hawks on the Wing with lots of Hawk ID resources, hawksonthewing.com, and is also our website manager for HMA. Let us know where you're joining in from today in the chat. You can add if you've had any interesting raptor sightings. We always like to hear that. I saw my first broadwing of the year right overhead, just here in New Hampshire. And we have a backyard broadwing that we put a transmitter on last year. So I think it's right around Louisiana right now. So we're excited to see that bird return. We are very excited to welcome Eden Ravecca to our Lunch and Learn, who's been researching black kites, their ecomorphology and migration in Spain. And it's a species that I am excited to learn more about. We don't often hear about that in the US or during our Lunch and Learns. Before Josh introduces her, I'll give you a little background on HMA for those of you who may be new to our organization. We're a nonprofit and we provide support to the Raptor Migration Monitoring Network across the Americas. So there's about 200 Hawkwatch sites that are actively submitting data spread out through North, Central, and South America that monitor migration in the spring and fall. And they report those data to our database, hawkcount.org. We provide resources to the monitoring network, data support, protocols, data sheets, a number of annual grants for various things. We also offer educational resources, Hawk ID materials, junior Hawk Watcher guides, and we're part of the RPI, the Raptor Population Index, which produces conservation assessments and population trend analyses using all that hawk count data. You can learn more about what we do at hawkmigration.org or check out our database, hawkcount.org. As always, we are recording and we are also live streaming on our Facebook page. You can view any of our Lunch and Learn programs on our Facebook page or on our website, usually within a week or two after the presentation. We're muting everybody. That's the best way to avoid distraction, but we'd love to connect with you as always. So we encourage you to use the chat and ask questions or make comments. Josh is going to read questions to Eden at the end of the program. And lastly, if you don't already receive our e-newsletter, it's a great way to get updates and news on tours and events like this. You can just put your name and email address in the chat or send it directly to me and I'll add you. So go ahead, Josh.
Okay, thank you, Julie, and welcome all. And thank you so much, Eden, for taking the time out of your schedule to be here. I know a lot of us, including Julie and I, are really excited for this talk. So a little bit about Eden. She is a PhD candidate in the Ecology, Evolution, and Behavior program at Boise State University, where she studies the ecomorphology and migration strategies of black kites. She previously completed a master's degree in raptor biology at Boise State, where she studied prairie falcon movement ecology in the sagebrush steppe of southwestern Idaho. She's worked in raptor research for the past 6 years on a wide range of projects. Prior to graduate school, she volunteered in raptor rehab and education and outreach, worked as a burrowing owl field biologist for the Florida Fish and Wildlife Conservation Commission, and worked as an environmental scientist in northern Colorado. Her broader research includes movement ecology, molt patterns, ecomorphology, trophic interactions, ecological disturbance and recovery, and predator-prey relationships. Thank you again, Eden. I'll hand the floor to you.
Awesome. Thank you so much. Good afternoon and welcome. Thank you all for joining me. Today I'll be presenting on how wing shape varies with the timing of migration among Western European black kites. Let me just move this sidebar out of the way. Perfect. Okay. Before I get into the details, I want to take a moment to acknowledge everyone who made this project possible. I want to start by thanking all the partners and collaborators and the students that have supported this work. This project is funded in part by NSF's International Research Experiences for Students program and is a collaboration between Boise State's Raptor Research Center, the Department of Biological Sciences, the Intermountain Bird Observatory, and Fundación Migres in Spain, and has been helped with from several outstanding students and field partners. So a huge thank you to Julia Parker, Amethyst Tagney, Liz Jessmore, Anna Connington for all their hard work and for making field days both productive and a lot of fun. So with that, let's step back and talk a little bit about the background of my research. And so natural selection has shaped the wing morphology of birds for different kinds of flight. For example, as most of you here might know, a soaring bird is shaped very differently from a bird that uses powered flight, and each have their own costs and benefits to a particular wing shape. And these costs and benefits can create different selective pressures among different species. But it doesn't stop at differences between species. There can also be subtle variation within a single species depending on the environments that individuals experience. We can see this concept clearly in studies of songbirds. For example, a study on northern parulas shows how variation in wing shape within the same species. Birds living at higher elevations have different wing shapes than those at lower elevations, and that kind of shows how environmental differences can shape physical traits. And for raptors, however, we know much less about this kind of variation within a species. So building on that and thinking about how flight behavior relates to wing shape, much of what we know about this comes from studies of songbirds. So in birds that migrate long distances, wing shapes often reflect a balance between efficient flight and the demands of migration. So longer, more pointed wings tend to make flight more energy efficient. And so birds that migrate farther often have these types of wings compared to birds that travel shorter distances. And so in this example, wing A is longer and more pointed, which might represent a bird that migrates longer distances. Wing B is shorter, it's more rounded, and that might represent a bird that migrates shorter distances or maybe doesn't migrate at all. So for raptors that migrate different distances, we might also expect to see a range of wing shapes that reflect those different migration patterns. In 2023, I was in Spain and I was working with IBO as an intern, documenting black kite molt patterns and using standardized photographs. And as I looked through the photos, I noticed a surprisingly wide range of wing shapes, and no one really knows why this variation exists in black kites. That variation created a really good opportunity to explore how wing shape might affect things like flight efficiency, movement behavior, and migration strategies, and thereby offering novel insights into evolutionary processes. So black kites use a wide variety of migration strategies, and they show a lot of individual variation in wing shape. They can also be trapped in very large numbers during migration at the Strait of Gibraltar, a location that is also a really important migration bottleneck for Western European soaring birds. As such, they're a good model species for exploring questions related to ecomorphology, or in other words, the relationship between ecology and shape or form for raptors, especially by using in-hand photographs. So based on my observations, I wanted to dig a little bit deeper and ask what factors might actually drive that variation in wing shapes of black kites. So as part of the overarching research question, I looked at whether migration distance, age, or sex might help explain the differences in wing shape. In the future, I'll also account for molt, since missing or growing feathers can, of course, affect wing shape. But for now, I just focus on three main factors, which is capture date, sex, and age. And my response variable, or the way that I'm measuring wing shape, is called a hand wing index. And I'll explain that in a little bit later when we get to the analysis section. But in a nutshell, it's just how long and pointed wings are. I used capture date as an indirect way to estimate migration distance because banding recaptures at our study site show that birds breeding farther north migrate later in the season. And so birds that are trapped early during migration are likely originating from a closer population, while birds that are trapped later in the migration season are coming from farther north. And so soaring birds that migrate from Western Europe down through southern Spain, they will cross the narrowest point of open water at the Strait of Gibraltar. And then they continue southward. For black kites, they'll migrate all the way down to sub-Saharan Africa. Now, open water is already an ecological barrier for a soaring bird because of the lack of strong thermal updraft or lift, and because they're built to soar. So they're built to use minimal energy. They're not built for powered flight. And so they can't just like fly across from the coast of Spain over to the coast of Morocco. They need to use thermals to gain altitude over land, such as in southern Spain, and then they use a tailwind to help carry them across. But winds at the Strait of Gibraltar are predominantly westerly or originating from the west, or they're easterly, which means they're originating from the east during migration, which means that for a bird that's traveling north to south, they're almost always encountering a crosswind at this point during migration. And when the winds blow from the west, they're typically cooler, they're milder, and they're really good for migration. So for example, here, a bird circles up in a thermal just west of Tarifa, Spain, and then uses that westerly wind to drift across to the Moroccan coast. They start a little bit west of that narrowest point. They don't get displaced too much because the winds are lighter, but it still carries them over to the other side. When the wind blows from the east, they're typically much stronger and not as good for migration. And so in this example, a bird circles up in a thermal just east of Tarifa and then tries to use a really strong easterly wind to drift across to the Moroccan coast. They're still accounting for some displacement, so they start a little bit east of that narrowest point, but they end up getting displaced too much because the winds are much stronger. And instead of making it to land, they end up in the middle of the Atlantic, which is not a great place for a bird to be, especially one that isn't built to use powered flight. So instead of taking that potentially fatal risk of migrating when winds are too strong, they decide, hey, I'm not going to attempt to cross, and instead I'm going to wait this out. I'm going to wait until conditions improve. But meanwhile, there are still birds that are incoming from the north each day. And as long as the winds are strong, they just start to pile up by the thousands in southern Spain. And this creates a really beautiful phenomenon, which we call a milanada, which just means that there's thousands upon thousands of kites swirling around Tarifa in southern Spain, and they're just waiting out the winds. So they're either swirling or they're just waiting on the ground. And for me and for other researchers who trap birds for studies, this means go time. So there are huge numbers of birds, and we get ready to offer them up a free meal in exchange for some data that we need to collect. So before I get into trapping, let's zoom into Tarifa. We have a really cool site where we trap black kites. Our partner organization in Spain has been trapping and banding birds for almost 20 years. And so they have the method down and they have a really rich historical data set. Given that I'm interested in wing morphology, this is the perfect place to trap and measure black kites. So these photos are at our site, and here we're about 1 mile from the coast of southern Spain. It's this really large open pasture where we set up a trap that's nice and visible from above. Also, a very cool and unique component to our site is an old military bunker that is partially underground. And in the bunker is where we actually trigger our trap to close and where we process the birds so that we're out of the sun, we're out of the heat, and out of the intense winds. Before we can catch any birds, we have to start with what we call landscaping day. It's not exactly anyone's favorite. It's the part of the job that kind of no one looks forward to. Clearing out overgrown vegetation, navigating really rough terrain, and plenty of sharp, stubborn plants that do not want to move. But it's what makes everything else possible. So turning a messy patch of land into a safe, functional trapping site. In this past year, we had an almost entirely female crew out here doing the hard physical work, but we absolutely crushed it and we looked good doing it. And then here's what our walk-in trap looks like once the plants are cleared out and the trap is set up. And then we do something that we just call bait and wait. So we use meat, bones, and scraps to lure the kites, which have very strong scavenger tendencies. And that bait is donated to us by a local butcher in Tarifa. So this is what it starts to look like once we get the trap set up for the day. You can see there's a bunch of black kites flying around, and we've even got some that are already checking out the trap. If we zoom into the trap, this is what we start to see. They're gathering around, they're looking interested. And one thing that is super cool about these birds is that they're social and they take cues from each other. So they are like constantly vocalizing, especially once one bird has found something interesting like food, and then more and more start to show up. So at first, they're curious, but they're hesitant, like who's going to be the brave soul that enters the trap first. They all watch each other and wait to see if anybody will commit. And then suddenly, one brave or hungry kite decides he's going to go for it, and the others say, "What the heck? I'm coming too." And it's like a feeding frenzy. The kites see each other, that they have something that they want, and they're all in. So it's really like absolutely fascinating and thrilling to watch these kites just descend from the sky to our trap. So once we have a good number of birds in the trap, it's time to close the door. And we do this from inside the bunker. And like I said, once a bird is in, they all start to go in. So it can be a little bit of madness. You have to wait for the entry to be clear of birds so that we can safely close the door without hurting anyone. But that means that sometimes we catch more birds than we meant to. So after the door is shut, we wait a little bit longer. And the reason for waiting is that because once those birds are in, they immediately start gorging themselves on the bait, and they get these huge crops. And so if we were to go in right away and start processing the birds, we risk them throwing up the food that they just ate. And so we don't want that for our sake or for theirs. And so normally we wait like an hour or two for them to just digest before we start processing them. And they just hang out in the cage. Earlier, I was saying when it's really, really windy, a lot of birds will just stay on the ground. This is normal behavior for them, as you can see in the photo on the right. And so they're totally content just sitting on the ground, hanging out after they got a free meal. Once the birds have had a chance to digest, that's when we go in and we start to round them up. Sometimes there are too many kites in the trap, and so we choose 20 or 30 birds to fully process, and then the rest just get really quickly aged, banded, and released. For the birds that we do fully process, we carefully place them into cloth bags. We get them out of the sun and into the bunker. And in the bottom photos, you can see the entrance to the bunker, and in there is where we do all of the processing. So we line up the birds on the ground, and there's one person that's designated to just hang out with the birds, make sure that they're calm. We spray down their feet every few minutes to make sure they're staying cool. And then one by one, we start banding. And usually our processing time is about 5 to 6 minutes per bird. And then they're back out the door ready for release. So after banding, we take standard morphological measurements, like measuring wings, tail, weight, that kind of thing. And then sometimes we draw blood. And for my project, they also get their photos taken too. And so we do this whole series of processing across 2 to 3 different stations, like processing stations. So there's the banding and measuring station, and then from there, they sometimes go to the blood sampling station, where we might take a small amount of blood to sex the birds, or maybe eventually do some genetic work. And then finally, they come to the last station with me. And this is where the standardized in-hand photos happen. And it kind of feels like stepping into a tiny field studio. So inside the bunker, I've set up like a pop-up photography space, complete with adjustable lighting and a gridded backdrop. And we give each bird a very efficient little photo shoot. So 7 photos in total, including the top and underside of each wing, the tail, and then the left and right profiles. And it may sound like a lot, but we move really quickly. Like I said, from start to finish, each bird is only in processing for about 5 to 6 minutes before it's ready to go back outside. And then on the right, here's a picture of what those photos look like with the gridded background. And then here are just a few photos of juvenile kites after their photo shoot, including our 100th bird of the season, this past season. It's safe to say that we're all pretty charmed by them, especially the juveniles. So if we're moving a little bit ahead of schedule, we might take a quick moment to admire them and say thank you before they head back out on their way. So this is a really big operation. Teamwork is everything. So when we're processing a large number of birds, we might have 8 to 12, sometimes up to 15 people all working together in sync. And it becomes this massive coordinated flow. It kind of feels like a well-oiled machine where every step is focused on keeping the birds safe and minimizing their time in hand before we let them go. And here's just a quick little release video. All right, so those were our methods in the field. Now moving on to the analysis methods. So what happens once all the data has been collected? So the hand wing index is a way of measuring wing shape, specifically how long and pointed wings are. It's based on two measurements, the length of the longest outer feather and the length of the inner wing. By comparing these, we get a value that describes the overall shape of the wing. And so a larger hand wing index value means that the outer wing feathers extend farther, creating a longer, more pointed wing. And a smaller value means the wing is more even and rounded. And so here is what a surprising amount of variation looks like using black kites as an example. And what initially got me interested in developing this project. In this image, we have 3 individual black kites. All of these kites are adult or after second year birds. In the top panel is an example of a smaller hand wing index where the outer wing tips don't extend much beyond the inner wing tips. So an even, more rounded wing. The bottom panel shows a larger hand wing index where those outer wing tips project really far beyond the inner wing tips, and so a more elongated wing. So how did we quantify wing morphology in practice? Well, first, we used the standardized photos in hand. We photographed the black kite's wings against that gridded background. And then we use a photo processing software called ImageJ to measure the wings in the photos. Here's an example of what that might look like in ImageJ. So to process the photos, I first set the scale by drawing a line across a known distance in the image. And in this case, I set the scale using one of the grid squares, which is 2 centimeters in length. And then I carefully trace the wing. And then using the known scale, ImageJ can calculate things like aspect ratio, or I can measure the outer and inner feather tip lengths to get the hand wing index. And so we can also measure things like wingspan and area, and we can calculate measurements such as wing loading. So alongside the morphological measurements, we also needed a way to estimate how far each bird has migrated. And as I mentioned earlier, I'm using capture date as a proxy for migration distance. So assuming that birds breeding in areas such as Spain migrate earlier, while birds breeding farther north, such as in Germany, migrate later. In that sense, capture date reflects migration timing, and timing is an estimate for distance. Now that you have a sense of the variables, let's look at how we analyzed the data and what we found. And so the model that included date and age explained the data the best. The full model with date, age, and sex was the second best. And so the main takeaways here are that the strongest results comes from the model that's just using date and age. There was a model that was just age and sex without date, and that was one of the worst. And so this kind of suggests that timing, and by extension, migration distance, matters more than age and sex alone. Now for the fun part, here's some figures to visualize the model results. In this figure, the x-axis shows the capture date. These are the dates when we trapped the birds, which was dictated by the weather. So we did not trap continuously every single day. The y-axis shows the hand wing index. And remember that a more elongated wing has a higher hand wing index, whereas a rounder, broader wing has a lower hand wing index. So in our data, most of the variation in hand wing index or wing shape is being explained by that capture date. So as migration progresses, we see a decline in hand wing index. This translates to more elongated wings earlier in the season when those closer populations are migrating versus rounder wings later in the season when the farther populations are migrating. This was actually an unexpected result because it's the opposite of that pattern that we see in songbirds. And so I'm excited to try to figure out why this might be the case. And then we take a closer look, this time broken down by sex. This figure is just essentially reiterating that sex does not seem to explain variation in hand wing index. This is the same data set from before, only this time showing males versus females. So females in the coral color, males in the teal color. Both males and females are showing the exact same pattern across the season, which is that decline in hand wing index. And then looking at the same relationship, but now broken down by age class, this figure is reiterating that age does seem to affect hand wing index. And so again, this is the same data set from before, but now showing juveniles in the coral color and adults in the teal color. So the adults are the after hatchier birds, and the teal are showing a strong decline in hand wing index throughout the migration season, whereas juveniles or hatchier birds in the coral color have the same hand wing index kind of throughout the season. And this sort of makes sense because age differences between hatchier and after hatchier birds is likely reflecting a structural or developmental difference in wing shape. So this could mean that younger birds have more uniform wings that are shaped for learning how to fly well or for controlling their flight. And adults might have wings that prioritize efficiency or optimization or something else. And so altogether, these results point to a clear relationship between wing shape and migration behavior. Black kite wing shape is closely linked to migration timing, with earlier and later migrating individuals showing distinct wing morphologies. Looking more broadly, climate change could alter the timing, the volume, and the routes of migratory birds that are passing through critical bottlenecks like the Strait of Gibraltar. And changes in wind patterns or other environmental factors could also shift selective pressures on wing shape. So understanding the variation in wing shape and how it relates to migration can help provide insights into potential adaptive capacity of raptors, especially under changing environmental pressures. And to wrap things up, this is just a fun little video of me clicking back and forth between two birds with pretty striking difference in their wing shapes. Both of these birds are adult birds. And I think that this sort of illustrates kind of the beauty of standardized photos. So just pay attention to the outer hand portion of the wing where the arrow is pointing. Okay, I think I kind of breezed through that because like that didn't take very long, but that's all that I have for you. So thank you all for joining me today. I'm super happy to take questions now if there's questions in the chat.
Yeah, there are. Thank you, Eden. Really great talk. I found, especially looking at, how they're migrating through the Straits of Gibraltar for me was really special. So thank you for sharing that. We do have a few questions. First off, kind of near the start when you were talking about trapping, they're curious, what do you use for the bags?
Oh, these are similar to the bags that we use for songbirds when we're banding songbirds at songbird banding stations. I'll go back because there's a picture. They're just like little cloth bags with a drawstring. So right here in the top left, You can see them in the bags, but they have their feet and their tail sticking out. And so we kind of just like close the bag. It's not too tight or anything, just so that they're kind of face down in a natural position and their feet are out so that we can spray them down.
Awesome. Awesome.
Yeah.
And that came from Sandra Kinsey. So thank you for that good question. Jerry Toll is wondering where you get the bans. Is banding regulated by country or the European Union?
That's a really good question. I think that the banding in Spain it might possibly be regulated by both, but I think that the bans come from like the Spanish organization that like manages the banding efforts in Spain.
Okay, thank you.
Yeah.
A few people are wondering if you've explored putting transmitters on any of these birds.
I haven't, but it's something that I would love to do. So I think one of the very cool next steps could be to see birds that have different wing morphologies and put transmitters on them and then measure things like flight performance. So, like when they're migrating, you put a transmitter on two different birds with different wing shapes. Does that affect like how fast they get to their wintering grounds, how fast they get back up to their breeding grounds? Is there any difference in flight performance? I think that would be really, really cool to explore. I did not have transmitters for this project, but there has been a lot of projects in the past, like a lot of work done with black kites putting transmitters on them, looking at their crossing behavior at the Strait of Gibraltar, looking at differences between like age classes and things like that. So there is a ton of data out there. And I'm hoping to actually use some of that data in future research questions as part of my dissertation. So looking at some stopover ecology and different behaviors during like stretches of really bad wind at the Strait of Gibraltar.
Yeah, that would be really interesting. Thomas Salo is asking why black kites are migrating earlier than North American species.
Oh, that's a good question. I actually don't know why, but they do migrate quite a bit earlier than I think we expect, based on like what we see in migration here. So they start migrating in late July. They peak around the second week of August, and then it tapers off. And like usually by mid-September, there's no more kites migrating, which
Mhm.
is kind of peak migration for like a lot of the species that we see in North America. So yeah, I'm not sure why they go so much earlier. That's a good question.
Yeah, I'm excited to see that we have both Neil Proprocki and Nick Aliotto on the line. For that previous question, these are two great resources if you haven't met these gentlemen to talk about transmitters and such, just FYI. But Neil actually has a question for you. He's wondering if you accounted for active molt within your analysis. Based on your ASY photos, it looks like some individuals are still molting at capture. More active molt earlier in the migration season might influence your HWI measurements.
Yeah, 100%. So I haven't actually in the preliminary analysis, but it is included. Oh, let's see, where did I put that? I think it's a little bit earlier. I will account for molt when I more officially do the analysis because, yeah, depending on where they're at with molting, um, there could definitely be, I don't know where the slide is, but there could definitely be differences in that hand wing index. And so it's important to account for that. Another thing that's kind of interesting with these birds is that we know very little about their molt patterns, but from what we understand, they typically start molting on the breeding grounds and then they suspend their molt during migration and finish molting at the wintering grounds. I would say 98% of the birds that we trap are actively molting on migration. And so they're not quite doing exactly what we would expect them to do. So that's like another part of my dissertation that comes a little bit later too, is also trying to understand these molt patterns and a little bit of individual variation, like why is it that birds are molting during migration and does it matter where they're migrating from, how they're molting as well?
Yeah, thank you.
Mhm.
Thomas had an additional question. Is the hand length simply a feather length difference?
It's a ratio. So there's a little slide on that as well. So it's basically a ratio of the length of the longest primary, which is the wing chord, and the length of the first secondary, which is what we call the S1 chord. And so if that difference is very close to each other, if the wing chord and the S1 chord are very similar in distance, that gives you like a rounded, shorter, broader wing. If the difference is really different between the wing chord and S1 chord, that gives you a longer, broader wing, or sorry, a longer, more elongated wing. And so that looks kind of like this, small hand wing index on the top and then larger hand wing index on the bottom.
Okay, thank you. Mike Street is wondering if you get any retraps year to year.
We do see banding recaptures. I'm not sure exactly how many are birds that were banded in Spain, like at that site, and then recaptured at that site again. But they do get banding recaptures from all throughout Western Europe, which is how we understand that the birds that are migrating from farther north in Germany are migrating later in the season because they're usually recapturing those birds at the tail end of the migration season versus earlier in the season, they're catching birds that are originating from Spain. So we do get a lot of recaptures. Is very cool to see. They also have, there's a count site in southern Spain as well, where they have seen birds with transmitters fly by. They see birds with wing tags sometimes. So it's just like a really cool site where birds kind of get condensed. And for that reason, we do see a lot of like resightings and recaptures.
Interesting.
Mhm.
Our last question is from Gordon Peterson, who's wondering if the wind machines that are seen in the background of some of your photos cause problems with the migrating raptors.
Yeah, I think that they do. There's not been a ton of work done on the interaction between wind turbines, or officially anyway, the wind turbines in southern Spain with migration. But I think from what we understand, it doesn't affect black kites as much as it does other species, such as griffon vultures. There's actually another student in my lab. Her name's Anna Connington, and for her master's work at Boise State in raptor biology, she is looking at the interaction between wind turbines and the migrating soaring birds through there. So hopefully we'll have some more answers too with her analysis that she has coming up.
Awesome.
Yeah,
Well, Eden, I have to share, there's just a plethora of people sharing how much they appreciated your talk and what a great presentation it was. So thank you for that.
thank you.
Julie, I'll go ahead and hand things back to you after thanking everybody who joined as well as engaging with us in the chat. So, Julie, back to you.
Hey, great. Thanks, Josh. And thanks so much, Eden. That was wonderful. Super interesting topic, really. And I love learning just about how you conducted your research, particularly the trapping process is so cool. It looks like a bander's dream, being able to catch that many, which is pretty not typical for a, raptor banding station.
Yeah, definitely. It was
So
also a
thank
huge
you.
change from my master's project where I think I was averaging about 100 hours to catch one bird. And then, in Spain, in a couple hours, you can catch maybe 80 to 100 birds or more, which is crazy. But it also, like, it's really exciting and it's so unique. It also can be really stressful because you, like, have a lot of birds. And I'm like, the entire
Yeah,
time, like, oh my gosh, I got to get these birds out the door. Like, I can't hold them for a really long time. So it comes with its
right.
own, like, unique challenges, but it's so awesome too at the same time just to be able to
Wow.
see that.
I bet. Yeah, what an opportunity for
Yeah.
research. Well, thank you so much. And for next month, on May 13th, we're going to be hearing from Zoe Benerbo, and she's going to be talking about her research, breeding ecology of prairie falcons. So that's another species we don't hear a lot about. And during our lunch and learn. So you'll be able to register for that on our Facebook page and our website soon. We just need to set up registration. That's coming soon. And if you receive our e-newsletter, you'll get an invite for that in early May. So that will be a good one. And if you enjoy lunch and learns and enjoy being part of this group. We encourage you to join our kettle and become a member of the Hawk Migration Association. We rely on memberships to provide all our programming, just like this program on Lunch and Learn, and it helps us keep Hawk Count up and running and offer support in many ways to the monitoring network. So we'd love to get your support, and you can go to hawkmigration.org/support to check that out. It's also Raptorathon season. That's our spring fundraiser. And we have about 10 teams currently fundraising right now. And those teams are raising money for their local hawk watches to keep them afloat and for various raptor research efforts and Humana or HMA programming. So you can support these teams at hawkmigration.org/raptorathon. We'd love to have your support for that. And we also have a big sale that's still happening for merchandise on our website. So check that out. And thank you all for joining today and to Eden for presenting. And we hope to see you again next month. Thanks a lot.